We're clear here today. 5-4 inverses and square root functions is what we're dealing with. Our goal is to be able to find the inverse of a function and to be able to graph square root functions. Okay? So I want you to work through this warm-up with your partner there. Okay? Should be on the back of that note page. All right. So here we go. Let's see inverse and square root functions. Let's see if we get this graphed correctly. So we're graphing 2x plus 5. So y-intercept. So recall M and B, right? Y-intercept is 5. We rise 2, run 1. Oops. So hopefully everyone did pretty well with that. All right. So you get a graph, or at least you have your dots there look like that.
On one of them, you went down 3 and over 1.
Did I go down too far on one?
After you pass the X.
The one on the
Right here?
Yeah.
Unbelievable. That messes up all those points. Well, I'm going to connect the ones I have there. Second time there. It looks like I'm lined up about correct. All right. There is y equals 2x plus 5. All right. Thank you for checking mine. Okay, and now we're graphing x equals 2y plus 5. Now, it's helpful if you put this in terms of y equals. So if I do that, notice I just switched the x and the y's here. So that's the inverse. I'm going to subtract 5 or subtract x and move 2. However you decided to do it. I'm going to work by subtracting 5. And then I'm going to divide by 2. So 1x over 2 minus 5 halves. Okay, or x over 2. It's not a 2. There we go. All right, so usually we would be used to seeing this in that form. Okay, and minus 5 halves is negative 2.5. So we go down 2.5. We rise 1, run 2. Awful lot of dots. All right, we end up with something that looks like that there. All right, and that is x equals 2y plus 5. Now, how many got something like that? Okay, now we need to graph the line y equals x, which I'm hoping everyone knows is the line that goes 1, 1, 2, 2, 3, 3, 4, 4 through the origin. Looks like that right there. Those lines, everyone's eyes and ears focused up here, those lines are called inverses. Pay attention. Graphically, inverses, what kind of relationship do they have graphically? Cool?
They all end up at that one point right there.
So right here?
Yep, right there.
Okay, they intersect right there. Okay, yeah?
They reflect the y equals x axis, or yeah, like that line. They reflect it evenly.
Yeah, this is a reflection. This line right here is a reflection of that line. It's a reflection over y equals x. If you guys recall back in geometry, now if you had me or Vogel, we actually used this paper here. Now I'd actually have to be able to get that off of there. I'm not using, there we go. All right, use this transparency paper. Did anyone use that? Okay, so a few of you, or a good chunk of you had us. Let me see if I can actually find a pen. This pen will work. Let's see, if I trace my original line, okay, And I'm just going to trace in a part of the line of reflection here, at least up to there. Now, notice if I flip that line over, that line of reflection, I'm now at that line.
Whoa.
Okay, we line them up. It's a reflection. An inverse, graphically, is a reflection over the line y equals x. So if you take an equation, find its inverse, and graph the original and its inverse, it's a reflection over y equals x. That may not seem like a big deal to you right now, but this year we introduce inverses. Next year you work with them quite a bit. Okay? You'll keep building on this. So this is a brand new concept for most of you, dealing with inverses, at least in graphical form and equation form. So understand that if you have an equation and you graph its inverse, it reflects it over the line y equals x. Okay? Everyone with that? Equation y. If this equation and this equation, if those two equations are inverses, what have I done to take this and find its inverse? In equation form now. Ignore graphs. In equation form, how did I find its inverse? Talk with your neighbor about it. Okay, volunteer. One person, same person that answered the last question. I even told you. What do I do? Yeah? Yeah?
Take the reciprocal of m and
Even more simple. We're trying to be too technical with it. To get from here, from this equation to that equation, what did I do, Quay?
You switched x and y.
I switched x and y. In fact, I switched x and y in the equation. That's it. That's all you do. To find its inverse, you switch x and y. Totally really. Notice this. Hopefully, I mean, some of you will be in total awe here. Notice this point right here.
Yeah, that's 0, 5. There's 5, 0.
That's the order pair 0, 5. If I follow that point through the line of reflection and hitting it at a right angle, it's going to hit this point right here, which actually happens to be the order pair 5, 0. Now I can draw that line there so you could see it, but there is its reflected point. Notice what I've done. You just switch x and y. Any point in its reflection. So for instance, this one is the order pair -2, 1. So if I go to 1, -2, I should have its reflection. Okay? So you're just switching x and y's. All right? Those are reflections. You need to somehow note this put this in your notes. Remember, we just went from graphing quadratics last section and standard and vertex form, and now all of a sudden we're doing this stuff, which looks completely different. Okay? Somehow know that really all you're doing is switching your x's and your y's, whether it's a coordinate or if it's in the equation. All right. Questions? So, going to number 1, example 1 on our assignment. Here we've got it. I gave you graph paper so you can graph some of these. Let me actually give you your assignment. Okay, everyone ready for it? Yeah. Don't scribble anything. But today's assignment is example side. In fact, I'll write it right here. Example side 1 through 21. Mixed side 41 through 49. Okay? So today's assignment will be the example side 1 through 21, the mixed side 41 through 49. We will do some in class. For instance, number 1. You have graph paper. And I even started with number 1, so those of you that are type A'ers, you're not going to get frustrated. You just start with the first graph. I know. You're welcome. Okay? So, graph each function and its inverse. Then write the equation of the inverse in terms of y. Now, your directions do not say in terms of y. I want all equations for inverses put in terms of y. In other words, that means, if you didn't know what it means put it in y equals form. That's what, okay? All right, very good. Go for it. Work with your partner there, number 1. Okay, ladies and gentlemen, here's our first one. Everyone's focused right here, please. Done talking. When I divide by 3, this is 1x, and I have to divide both parts by 3. Now, you're going to see this a lot this year. So that means I have 1/3 x plus 1 now. Okay, that is the same equation, right? So if you didn't get that correct, then you're going to have a hard time graphing. This is your b. That's your slope. So we go to the y-intercept of 1. We rise 1. We run 3. Make sure you're checking me again. Oops. Too many dots, man. All right.
No, I messed up the one before that.
Oh.
You got yours, McCoy?
1, 2, 3. Oh, yeah. Oh, right there I messed up. All right. Everyone got that line?
Yes.
Other than me, who can't seem to graph right? When you label it in its original form. Okay, inverse. How do we find the inverse?
Switch X and Y.
Switch x and y. So now we have x equals y plus 3 over 3. So we just switch, make that x, make that one y. And now we have to solve for y. First thing, get rid of a fraction is to multiply both sides by the denominator. So I now have 3x equals y plus 3. So we multiply that out on both sides. And then subtract 3. I have 3x minus 3 equals y. If it makes you feel better, you could rewrite it so it looks like this. Good. We go down to negative 3. We rise 3. Run 1. Just notice I'm doing this in pen, and I haven't been able to plot most of my points correctly today. So. I got them there. All right. So that is in the form of x equals y plus 3 over 3. Or if you wanted to put in that form, since that's probably the more accurate. Or it's not the more accurate, but it's the more readily used when graphing. Your quick check. How do you check it?
Draw the X.
Go ahead, Parker.
You take a point on the graph and then flip it, see if it's the same.
Good. If you take a point and reflect it over this line, this should be the same. So just maybe putting in the line y equals x, so you can see that these points are reflection. That point reflects to that. Okay, 1, 0 reflects to 0, 1. Right? Those 2 points reflect. 0, negative 3 reflects to negative 3, 0. That's your check. Easy check. Okay? Any questions on it? Okay, so you have your inverse, you have your graphs. I want you to do, let's pause for example 2, find the inverse of each function. Now, do you have to graph?
No.
No. F of x is the same thing as what? Y. So the first thing might be to write it with a y and an x. I want you to work on number 12 and number 16, please. And Madison asked that question. Is it the same with the quadratic? Well, there's our quadratical right there. So work on 12 and 16.
Do you want it in the form of
Y equals. Yep, and y equals. Okay, the inverse on number 12. We switch x and y, right? So now rather than y equals 3x plus 5, we have x equals 3y plus 5. And then getting y by itself. Subtract 5. And you get x minus 5 equals 3y. And then dividing by 3. And it's okay to leave it like this if you want, x minus 5 over 3 equals y. Or if you wrote it as 1/3 x minus 5/3 equals y, that's fine as well. Okay? Any questions on that? How many got it? Okay. All right. Well, let's try number 16. 16, to do the inverse. Once again, you have to switch x and y. X equals y squared now, minus 2. Do we get rid of the square root of the 2 first? 2. So we add 2, so we get x plus 2 equals y squared. And now what? Square root. Now, when I take the square root of something, I'm imposing it. I started a problem without a square root symbol. I now have one. Therefore, it needs to be a plus minus. It is awesome. You're right. I'll agree. Okay. I just can't. All right. Any questions there? All right. Very good. Go at it. That's your assignment today. You have the rest of the time to work. Hey, when is your portfolio page due? Monday. Good.